Okay, we have a video here that's going to describe to you an ellipse and how to work with the um, standard equation of an ellipse. And so if we move on to the next slide here, this is what an ellipse looks like. It's the blue ellipse. And there's some important terms that you're going to have to recognize and you're going to have to know. So this ellipse has a vertical major axis, and so this is the major axis right here. And if we notice that the minor axis is how I should be saying that, but the minor axis is the horizontal part. Now, it is possible to have it turned like this, where the major axis is horizontal. But I want to come back here. Okay, so some important vocabulary terms you're going to have to memorize. Right here, positive and negative A are going to be the vertices, the vertex points. And negative B and positive B are going to be the co-vertex points or co-vertices, if we talk about them both. Maybe I should put that right here. In this case, it's going to be positive, negative B, 0. There's 2 points represented in that. And then what's the other part? The foci. The foci is positive C and negative C. And the foci will always lie on the major axis. And in this case, it's that little point right there. I'm not for sure if that's that point, because that represents negative 4. 0, negative C, it just lies somewhere in this area. We're going to need some numbers here for A and B to figure out what C is, and we're coming to that. So, all right. So now let's move on to the next one and look at the horizontal major axis. Once again, here is the horizontal major axis, and you notice it's always longer, right? So that must mean that the distance between from 0 to A must be greater than the distance from 0 to B. So the distance of A must be greater than the distance of B, and then we get a horizontal major axis. Now in this case, once again, the distance of A is still greater than the distance of B. Even though it is a vertical major axis, the distance of A will always be greater than the distance of B when we talk about an ellipse. But you will have to pay special attention to that when we write equations, and I'll explain that in a moment. So once again, we still have the minor axis. We have the major axis. The vertex is always at the end of the major axis, and the foci always lies on the major axis. Co-vertex is at the end of the minor axis. And so, there we go. Just some definitions you're going to have to know. You may want to keep this drawing handy because we will refer to it quite a bit when we work on work. If we look here at the equations of an ellipse, the first one, if we look, this ellipse will have a horizontal major axis, and so therefore the equation for that looks like you see right there. You see x minus h in parentheses on top, and that's squared over top of a squared. And then you're going to add y minus k in parentheses squared over top of b squared, and it's equal to 1. And that's kind of important that you know that it's always equal to 1 here for the ellipse. And because we're going to be working some problems where it starts out with a different number, and we have to get it down to 1. And also, for the one here, where it has a vertical major axis, well, the top we can leave as the same. Let me try to write that more legibly. X minus h is being squared, and that's on top. And then on bottom, this is where it's going to be different. Y minus k is going to be squared. On the bottom, b squared goes on the bottom, and then a squared will go on the bottom underneath y minus k. And that's because a then is determined from here. It is half of that vertical major axis. And then b is still the distance from, the center here to the co-vertice. That would be b. And then from the center to the vertice, that would be a. Just like it was over here. From the center to the vertice is a, and from the center to the co-vertice, that's b. So this will kind of help you to pay attention as far as which number goes where, and whether it is a ellipse that is a horizontal major axis or an ellipse that has a vertical major axis. And it all depends upon the a squareds, where its location is. Of course, this always means that a is always going to be greater than b, and b is always greater than 0. So that'll come in handy, because then that helps us to identify, just from looking at the equation, helps us to identify which one is horizontal major axis and which one has a vertical major axis. And of course down here, the foci of the ellipse lie on the major axis, c units from the center, where c is equal to a squared. This should say minus. That should be a minus there, and that would be a typo. So minus b squared. So c squared is equal to a squared minus b squared. Okay, we're going to move on into some problems. So it says, write the equation of the ellipse with the given characteristics. The vertices are at positive 10, negative 10. Okay, so I'm just going to draw quick sketches here and hope that you can identify. So if this is negative 10, 0, and if this is 10, 0, and this is the, those are the vertices, so then we know the major axis of the ellipse is horizontal. So if that's the case, then we're going to go x minus h squared over top of a squared. Remember, if it's horizontal, a squared goes underneath the x minus h part. And then, what do we have? Y minus k squared over top of b squared, and that must equal 1. And so when we go from here, well, what do we need? Well, we need the center, and the center is halfway between each vertex. So the center in this case is going to be 0. And we need to know a squared and b squared. Well, remember, a squared is from the center to a vertex, so which that's going to be 10 squared. And then b squared is, well, b squared is from the center to the co-vertex. And if we know that the co-vertex is supposed to be positive and negative 9, I don't know if you noticed that, but I changed that one to a plus. So then we're going to say this is 0, negative 9, and this here is 0, 9. So then this is the co-vertice, and so this distance is b. And so b is going to be 9, and so we're going to put 9 squared on bottom. What's 9 squared? That would be 81. What's 10 squared? That would be 100. and that's equal to 1. So ideally, this drawing probably should be happening in your head. You should be able to see that in your head. If not, go ahead and sketch it out real quick. But here's the equation of the ellipse. Okay, so let's look here. It says write the equation of the ellipse with the given characteristics. The vertices are going to be 0, 6, which is something here, and 0, negative 6, which is something like this. And so if those are the vertices, that means that the major axis is vertical. The co-vertices are at 5, 0, and negative 5, 0, so it should look something like this. So this is going to be A, and then this one will be B. Well, A in this case, 0, 0, 6 is that point, so A is equal to 6. And then B is equal to, well, if this point here is going to be 5, 0, the distance is 5. So it says write the equation of the ellipse with the given characteristics. All right, so we're going to have x minus h. Well, h is 0. So you're going to have x minus 0, which is x. And then you're going to be adding y minus 0, which is just y. And then we square both of those that's on top. Now on the bottom, remember, since this has a vertical major axis, a squared, which is 6 times 6, because this is a, so a squared goes on the bottom. So let's write that as 36. And then underneath x, the x minus h part, in a vertical major axis, b squared will go there, and that will be 25. And we know for an ellipse, it's always equal to 1. So just by looking at the equation, how can you tell that it's a vertical major axis? Well, which one is larger, 25 or 36? 36 is larger, so that must mean a squared is 36. And then a is equal to 6. And remember, a is greater than b, which is greater than 0. So 6 is greater than 5, which is greater than 0. And that's how you can tell that it's a vertical major axis, is by identifying a squared and b squared, and a is always larger. And if a is underneath y minus k, then you know it has a vertical major axis. Something similar, but slightly different. Okay, so if we look here, we want to write the equation of the ellipse with the given characteristics. And we have the foci of being 7, 7, 9 and negative 1, 9. And then the co-vertices of being 3, 12 and 3, 6. So what's important here? Well, maybe we should draw a quick sketch. Remember, the foci always lie on the major axis. So 7, 9, 7, 9, and negative 1, 9 would look something like this on a quick sketch, with this being the major axis. Now, halfway between negative 1 and 7 there is going to be the center. So halfway between negative 1 and 7, well, that's a total distance of 8. Half of 8 is 4. So I believe this is going to be 3, 9 will be the center. The co-vertices, remember the co-vertices are along the minor axis. So this one's going to be 3, 6, and it's also 3, 12. And doesn't that make sense? Isn't 9 halfway between 12 and 6? Yeah. Okay, so where are we at then? So we need to identify, we need to know what A and we need to know what A and B are equal to. Well, how are we going to figure that out? Well, we know B. What's the distance between the center, and the co-vertice. Well, I believe that's 3 spaces, right? From 9 to 6 is 3, and 9 to 12 is 3, so B is going to be 3. Now, A goes from the center to the vertex. The foci is not letter A. But if you do remember, the foci is going to be C. So what is the distance from, what's that distance right here? From the center to the foci. Well, I believe if we are at 3 and we got to go to -1, that's 4. And if we are at 3 and we have to go to 7, that's also 4. So C is going to be 4. And now, didn't we talk back a few slides ago, right here? C squared is equal to A squared minus B squared. And so what we will do is we will say C squared, which is 4 squared, is equal to A squared minus B squared. So we know that this is 9, and we know this is 16. And then we know A squared is equal to, so we want to add 9 to 16, that gives us 25. And so we know A is equal to the square root of 25 plus or minus 5. So then we know A is going to be equal to 5. And then so I think from here we can write our equation. So does it have a horizontal or vertical major axis? It's horizontal. So then A will go underneath x minus h. So we're going to say x minus h. H in this case is going to be, there's the center, h is 3, over top of a squared, so that would be 5 squared, which is 25. We're going to add y minus k, and k once again is 9, over top of b squared, which is also 9. And we know that all this must equal 1. And there you go with your equation on how to write the equation of an ellipse when you're given the foci and the co-vertice. All right, so let's look at this one here. Alrighty, we're rolling along. I'm going to write the equation of an ellipse with the given characteristics. So now if we look here, this one has a foci of -7 and 5 plus the square root of 13. So 5 plus the square root of 13, we know 13 is somewhere between 3 and 4. So we know that 5 plus the square root of 13 is going to be somewhere between 5 plus 3 is 8, 5 plus 4 is 9. It's going to be somewhere between 8 and 9. So to graph that, we'll go to -7, and then we go between 8 and 9. And then to graph this one here, well, 5 minus 3 is 2, and 5 minus 4 would be 1. So it's somewhere between 1 and 2. So -7, somewhere between 1 and 2. And that would be the foci. And remember, the foci lie on the major axis, and so it must be a vertical major axis, which is kind of a big deal because when we have our formula here, a squared, since it has a vertical major axis, a squared goes underneath y minus k. Okie dokie. So this is where we're looking at. We have the foci there. Now the co-vertices are -13, 5. So -13, 5. And -1, 5. And so, what is going to be our center? Well, we know our center. We know that this right here, the x value is going to be -7, right? So the center, the x value is -7. What's the y value? Well, how far up do we have to go? Well, the y value is, I believe, up 5, right? There we go. So negative 7, 5 is our center. So let's go ahead and plug in some of those values. Negative 7, so that is x minus negative 7, which means x plus 7. And then we should have y minus 5, which is still y minus 5. Okay, so now how do we find b? Well, if the center is negative 7, 5, and this point right here is negative 1, 5, what's the difference? What's the distance between negative 7 and 1? I believe b then would equal 6. So then here, b is equal to 6, so that's going to be 6 squared, so we're going to put 36 there. Okay. All right, any questions here? Oh, we need to find out what a is equal to. How do we find out what a is equal to? Well, if you don't know what a is equal to, then we might want to look at, back at the very beginning, we had this page right here. Down here at the bottom, the foci of the ellipse lie on the major axis, c units from the center. So the foci is c units from the center, where c squared is equal to a squared minus b squared. So let's go back to our work and let's look at that. So we know the foci lie c units. So this distance is going to be c. Okay, so once again, let me get rid of some of this irrelevant information here. So what is the distance there? Well, we know that this is negative 7, 5, and then what is the foci? For that one there, the foci then was right here. Negative 7, and then 5 plus the square root of 13. So what's the difference there? And we're talking about vertically, so that means we're only looking at the y. We're only looking at the y difference, the difference in the y values, because we're going up and down, which the y values deal with up and down. So what's the difference there? Well, if we have 5 plus the square root of 13, and we want to subtract that 5 from it, well, what do we get? Well, 5 minus 5 is 0, leaving us with the square root of 13, and that is what c is going to be equal to. So we know what c is, we know what b is. So c squared is equal to a squared minus b squared. C squared is going to be the square root of 13 squared. We don't know what a is, so that's a squared. And b is going to be, remember, b is not 36. B is 6. So from here, square root of 13 squared is 13. That's equal to a squared. We're going to be minusing 36. So how do we solve for a? We want to add 36 to both sides, leaving us with 49 is equal to a squared. And you know if you take the square root of both sides, a is going to be equal to 7. And then a squared would be 49. Don't forget to put equals 1 to finish out your formula. And so here's the equation of an ellipse that has a vertical major axis. And we can look at the equation and know it's vertical because a is underneath y minus k. It says write the equation in standard form and identify the vertices, covertices, and foci of the ellipse. Alright, so your big key here is this right here, 250. In an ellipse, we like that to be 1. So what do we have to divide 250 by to get 1? 250. So if we divide the right side by 250, we have to divide the left side by 250, and that's everything on the left side. So on the left side, I know the zeros cancel, leaving me with 1x squared. over 25 plus, I know 25 goes into both of them, so it goes into this once and it goes into the bottom 10 times. So this is going to be y squared over top of 10. And so there's the equation in standard form. Well, since we noticed that it does not say x minus something, like x minus h, we know that the center is going to be 0, and also it doesn't say y minus k, so it's going to be 0, 0 is the center. I know that's not something that was asked of us to determine, but you do need this in order to identify the other stuff. Okay, so if we look here, which one is going to be a? Is it going to be 5 or is it the square root of 10? And whichever one is larger is a. So a squared is equal to 25, therefore a must equal 5, and b squared is equal to 10. This is where I'm getting these numbers from, and b must be equal to the square root of 10. So the vertex is 5 units away from the center. Well, if a is underneath the x, x minus h in parentheses, if a is underneath that, then it's going to have a horizontal major axis. If the center is at 0, 0, 5 units away puts me at 5, 0, and it also puts me at negative 5, 0. So that right there is going to be the vertex, or the vertice. Positive, negative, 5, 0. And remember, the co-vertices are distance away on the minor axis. And so if b is the square root of 10, that would be 0 square root of 10. 0 negative square root of 10. And to find the foci, we're going to use the formula that tells us that c squared is equal to a squared, which happens to be 5 squared, a is 5, minus, what's the square root of 10 squared? That will be 10. So c squared is equal to 15, and c is equal to positive negative square root of 15. And so the foci, positive negative square root of 15, it's close to 4. So the foci will be somewhere like that. And so that must mean that's going to be positive square root of 15, up and down 0, negative square root of 15, up and down 0. Remember, the foci always lies on the major axis. And let's check out this problem here. Let's look at this here. I want to write the equation in standard form, identify the vertices, co-vertices, and foci of the ellipse. Well, you know that the equation of an ellipse will always have 1, so we need to make that a 1. If we divide everything on the right side by 16, everything on the left side has to be divided by 16. So then our equation for the ellipse should look like this. And so that's going to work out better for us, because from here we can identify what the center is. We know that there's no numbers after x, no numbers after y. So we know the center is at the origin, 0, 0. We know a is equal to a number, and we know b is equal to a number. Well, a, remember, is down here below x squared, and what's down below x squared? Where that's a 1. So if a squared is equal to 1, what does a equal? Square root of both sides, a is equal to 1. And then down here you have b squared, which is 16. So if b squared is equal to 16, you take the square root of both sides, b would be equal to 4. C is going to be able to tell us the the distance of the foci from the center. So how do we find C? C squared is equal to A squared, which is 1, minus B squared, and B is going to be 4. So 1 squared is 1, minus 16. Got a problem here because we're going to get a negative number. What's the problem? We didn't pay attention to which one was A and which one was B. Remember, A is always larger. A is always larger. So in this case, is 1 larger than 4? No. So A is larger, so that means this is 4 because it comes from 16, and B is 1 because it comes from the 1 there. And so if A is larger and it's underneath y minus k, we know that this is a vertical major axis. The ellipse has a vertical major axis. And so therefore this is going to help us out because A squared, which is now 4, squared, so that's 16, minus B squared. And now we get a positive number, and C then would equal the square root of 15. Now I didn't switch those just so I could get a positive number. I switched those because I wanted you to notice that A was underneath y minus h, and that meant that it had a vertical major axis. Okay, so we identified what C is, but we really haven't identified the actual foci of the point. So if it's a vertical major axis, the center is at 0, 0. The foci is at square root of 15, so that's going to be vertical major axis. So we go up. That means we go left and right 0 and up square root of 15. And that means we go down. That's left and right 0, and that's down square root of 15. So right there is your foci. Your foci is going to be 0 plus or minus square root of 15. Or you could write out both points separately like I did down on the graph. Oh, identify the vertices, the covertices. It's pretty easy to do once you know what A is. Since we know A is 4, we know that you go left and right 0 and you go up 4. Well, once you know A is 4 and that it's a vertical major axis, and the same thing here, you're going down 4. So that would be the vertices, right? 0, positive, negative 4. And then the covertices, that's dealing with left and right, and that is letter B. So that would be 1, 0 and negative 1, 0. So from here, I mean, you can kind of see the ellipse, and that's a rough sketch of a graph. Covertices, positive, negative 1, 0. There we go. Yeah, I got it figured out there.